then this page will come. Here you need to click in the project design. Then if you are going to design the grid connected utility scale project, so for the big scale project you always need to select the grid connected. Here then this new page will open. In this new page there are many things which you need to select, like first one is the file name you need to give. So I am giving test123. Then again project name I am giving test123. Then this is the Meteo file which you need to create according to the latitude, longitude and altitude. So for example, I am creating a file here, test123. Country I am selecting India now. Location I am latitude, longitude I am selecting Rajasthan location. So then longitude you can consider 73.5. Altitude I am considering 150 meter. This actual data you can consider as per your actual site coordinates. Then you need to click on the import button. Now your Meteo file have generated. Here you can see the temperature of each month, then wind speed, then humidity, all the parameter in place. Then you need to click on OK. Now Meteo file generated in the name of test123. You can save. Done. Save now. Okay, now you need to save the project file again. Now click in the orientation. So in this time we are going to do the PV simulation for the FixTilt project. So if you want to FixTilt project with 23° of the tilt angle, then you need to consider 23 and azimuth. Later on we'll see what is the optimum angle for that particular coordinate. Then here you need to enter the system. So for the default exercise I am going to consider Longi module. So here let me find Longi module. So if Longi is selected, so here they have Longi 455 watt peak default module. Inverter I am going to consider SunGrow. Just for the exercise you can consider any other module as other inverter as well as per your requirement. So I am considering SunGrow. Here SunGrow I am considering their 3000 kilowatt inverter, means 3 megawatt inverter. So as per this inverter and module, the module per string default is coming around 27 number. Now you need to consider the number of modules, number of strings as well. So just for the reference I am considering 200 strings. You can see here promotional ratio is under, so maybe you can consider 300 here. So with 300 module your overloading is somewhere 23% and overload loss is something 0.4%. If you wanted to reduce the overload loss as well, so you can do the reverse engineering and reduce the number of string as well. So you can see here with around 16% of overloading, 14-15% of overloading. You can see here with 14% of overloading your overload loss is 0%. So I am going to consider 27 module per string, 278 string and overloading 14%. So now we'll go in the detailed losses page. So here we can consider free mounted module air circulation, because in the fixed tilt system it's free mounted. Ohmic loss, just for the reference I am considering DC loss 1.5%, AC loss I am going to consider 1.2%, just for the reference. You can consider as per your requirement as well. Here you need to consider the transformer losses, so I am considering 0.5 iron as well as 0.5 resistivity. LID, here you can see module efficiency is default 3%, so we'll keep these values as default. So LID I am considering 2% as default. Soiling loss, again depending upon the manufacturer, so just for my reference I am considering default here as well. IM, no need to change. Auxiliary, if you have some constant load like the trackers, so just for my reference I am considering 0.3 watt per kilowatt as a constant load. Then I am considering unavailability 0.5%. Then aging, it's again your decision. If you want, you can consider as for the basic PV Syst, no need to consider this aging as well. And now we can ignore self consumption, storage, horizon. Directly we can move to the near siding part. So near siding, if you wanted to do the advanced PV Syst simulations for the fixed tilt, you can create shadow object as well. So for the fixed tilt, you need to consider the PV table as sets. So here I am going to consider 30 number of trackers. Pitch I am going to consider 7.5. Length I am going to consider around 200 meter. Width I am going to consider around 4.5. So pitch we can increase a little bit more, around 9 meter. This you can keep as per your requirement. So you can see here it's 2 portrait design, and we have around 11,340 modules. We'll check these modules are enough or we need to reduce or increase. So yes, here you can see. Now you can do this as well. So with this you can divide this as per the array, consider as per your design. Now you can compute, close simulation, because we don't know 23 degree is the optimum angle or not, so we'll check what is the optimum angle for that particular location. So quickly we simulate this. Now we can see at this location 20 degree is the optimum angle. So we'll mention here, back to program, here we'll change angle from 23 to 20. Close, here, close. Yes, now you can simulate your PV Syst. Okay, now you can give the name. So fixed tilt with 20 degrees. Okay, save. Now you can see the report. So this is your report. So we have given the project name test 123. This is the coordinates which we given at the beginning. Here we have considered meteorology data, tilt angle. As per the optimization tool, 20 degree is the optimum angle, so we consider 20 degree. Pitch we consider in general 9 meter, but this again you can change as per your requirement. Then we have considered Longi module, 450 watt peak. Sun grow inverter we considered 3 megawatt. These are the losses which we consider. All are reflecting here. These are AC losses, auxiliary losses. Then this is the page number 3, which is again very important. So here you can see the layout which we created over there. In this page you are going to see what is the specific production, what is the produced energy, and PR. Everything you are going to get over here. This is the main results is going to reflect over here. This page is the not mandatory page, but if you want you can export. And this is the last page where you are going to see the loss diagram. Again very important. Everything you can see here, like what is the GHI, what is the losses, and how much energy you are going to inject. So yes, this page is now if you want you can save as this. You can setting, and if any of the pages you don't want you can deselect this, apply, and now you can see here and save PDF. You can save this as per your requirement, and yes, 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 yes. So here you can see this is the PV Syst report. Okay. So